So, hello everybody, welcome to the Chemopedia Academy. So, here are the two questions of the GATE examination. These two questions are from the quantum chemistry, which was asked in the GATE 2001 examination and GATE 2002 examination. So, so I would suggest just pause the video, solve the question by yourself, then watch the whole video so that you can find where you are finding the difficulty in solving these two questions. So let's solve these two questions. Okay. The first question, they have given the generalized wave function and they have asked to show that these eigenfunctions psi1 and psi2 of a particle in one dimensional box of length 1. Basically we have to show this wave function and this wave function to be a orthogonal. So I think we know about this orthogonality condition. So we know that for two wave function to be orthogonal, we have to, this condition must be satisfied. The condition is basically integration of psi1, psi2, beta equals to 0. If these two eigenwave function is, so if satisfy this condition, then we can say that these two eigenfunctions are orthogonal. So if we put n equals to 1 in this generalized wave function, then we got psi1 x. So psi1 x will be root 2 sine, there is n, if we to put n equals to 1, then it will becomes pi x. Okay, so the first eigenfunction is here. So if we put n equals to 2, if we put n equals to 2, then we get second eigenfunction, that is sine 2x, that is equals to root over 2 sine n pi x. If we put n equals to 2, then it will become sine 2 pi x. Okay, so these are the things which are given in the question. Now let's integrate and solve the integral. So the psi1, the psi1 is basically root 2 sine n pi x. So psi1 is basically root 2 sine pi x. Okay, and the psi2 is root 2 sine 2 pi x dx. And since it is one dimensional box of length 1, so we have to put the limit from 0 to 1. So we have to find this integral. So let's solve further. These 2 and this root 2 get multiplied and we got 2. We take these 2 out of the integral and write sine pi x, then sine 2 pi x dx. Here what is the limit? 0 to 1. So for further solving this, we have to know the formula of the sine A and sine B. So here's the formula, that is one of the trigonometric formula of sine A and sine B is equals to cos A minus B minus cos A plus B. So by using this formula, we can write 2 integral 0 to 1. This will become cos pi x minus 2 pi x become minus pi x. So it will become minus pi x and minus cos pi x plus 2 pi x become 3 pi x Okay, dx. Okay, we also know that cos minus x. Cos minus x is basically equals to cos x. So we can write this cos minus pi x equals to cos pi x. So let erase the minus sign because cos minus x is basically a cos x. So we can write cos minus pi x equals to pi cos pi x. Okay. Now we have to use the integral of cos x. So we know that integral of cos ax dx is basically sine ax sine ax, and the constant term is basically comes over the term. So this, by using this we can write 2. So by using this we can write 2, and if we integrate cos pi x then it will become sine pi x, and the constant term, the pi, will be the down, and we have also to put the limit. So limit is over here 0 to 1. So now another term we have to integrate this also. So this also becomes sine 3 pi x, and the constant term is 3 pi. So we have to put this down and put the limit, that is 0 to 1. Okay. So that's all for the. Okay, if we put x equals to 1, then this becomes sine pi, and we also know that sine sine n pi is equals to 0. Okay, and also sine 0 is basically 0. So sine pi is basically a 0. So if we put x equals to 0, then this term becomes sine pi, which will be equals to 0. And if we put x equals to 0, then that also becomes 0. So basically if we putting this limit, then it basically becomes 0. So now in the next term, if we put x equals to 1, then this will become sine 3 pi, and we know that sine n pi is 0. So we can write 0. If we put x equals to 0, then we know that sine 0 is basically 0, then this also becomes 0. So overall, if we solve this, then we get 0. So hence we can say that these two eigenfunctions are orthogonal, because if we integrate, if we use this condition, then it satisfies this condition. Okay. So moving to the next question. So this is the next question. This was asked in grade 2002. So they have asked the probability of finding the particle inside the left half of the one-dimensional box of length L. So 1D box, they have asked about the 1D box. So this is the ground state energy wave function, suppose, and they have asked about the left half. So this is the left half. Okay, so this is the left half and this is the right half. So they have asked about the probability of finding of the electron in this region. So they have asked about the probability of finding of the in the left hand side of the region. So this is the ground state energy. So wave function is so the wave function which is associated with the ground state energy will be psi 1, and that will be equals to root 2 pi m sine sine pi x by n, because n is 1, so we have to put n equals to 1. So n pi x will becomes pi x by n. Okay, now finding the probability, we have to integrate from the area. So they have asked about the left side of the area, so we have to put the limit 0 to L by 2. And the formula is basically the wave function, and we have to take the conjugate of the wave function, and we have to integrate the region in which they have asked. Okay, since this psi 1, if we take the conjugate, then also this psi 1 conjugate will basically be equal because there is no iota value. If there is some iota value, then the sign gets changes. So let's find or let's solve this integral. Okay, so limit is 0 to L by 2. Psi 1 is basically root 2 by L sine pi x by L multiplication with the root 2 by L sine pi x by L dx. Okay, so if you multiply this, then it will becomes 2 by L integral L by 2, and this sine pi x by L and this sine pi x will get multiply and it will become sine square pi x by L. So we know that the square of the unit trigonometric function, we can't do the integration. So we have to simplify this square trigonometric function into simple form. So for this, we know the one of the formula. I think so. For solving this type of question, you should have knowledge about some mathematical tools like trigonometric and integration and differentiation. Then only you can solve this type of question. So if you are not from mathematical ground, or if you have not learned, if you don't have any kind of math knowledge, then it will become difficult for you. So let's use the one of the formula of this sine square, that is basically equals to sine square x equals to 1 minus cos 2x divided by 2. So using this formula, we can write it 2 by integration L by 2, and we can write 1 minus cos L pi x by L. So we have to write 2 pi x by L. Okay, because in the formula they have used for x, they have used 2x. Okay, so here is pi xl, so we have to write 2 pi x, and we have to divide it by 2 also. Okay, and this, so we have to solve this integral for finding the property. So let's do in the next page. So we have to write in the simplified way. To simplify, if you simplify, then there was written L by 2. Okay, L by 2, an integral of half ds. If you simplify this, and the limit was 0 to L by 2 minus 0 to L by 2, and there was written, okay, there was written cos 2 pi x by L, and there was 1 by 2, so let it be here, the constant term outside the integral, and we have to integrate this. Sorry, the dx will be, so the dx will be here, not here. Okay, let me erase this. Let me erase this. Okay, okay. Sorry. I'm really sorry. Let me erase. Where is the eraser? Here is the eraser. We have to erase this and this also. Fine. Now let me take the pen and write it. So dx. Okay. Now let's integrate. So L by 2. Okay, if we integrate this, then it will become x, and we have to put the limit also. So limit is basically L by 2 to 0. And if we integrate this, then we will get cos we do the integration of cos, then it becomes sine. Okay, sine 2 pi x by L. Okay, 2 pi x by L. And this is the constant term L 2 pi, basically 2 pi by L is the constant term which we get downside. So if we write the 2 pi and limit is this 0 to 100. If we solve further, L by 2, and if we put x equals to L by 2 and x equals to 0, then it becomes like this and half. Let's put this constant term outside the box. So if we put here, then it will becomes L2 by 2 by L by 2 pi, and if we put the suppose if we put x equals to L by 2, so let me put it and show you sine 2 pi L, and if we put x equals to L by 2, so L by 2. Okay, the next limit is 0, so sine 2 pi L, and we have to put the next limit back to 0, and so L by 2. So this is 0, this is L by 2. If you multiply half, then it will become L by 4. Fine. Then we have to solve this also. L by 2 pi. And Cl. This L gets cancelled and this 2 gets cancelled. And we know this sine pi value is basically a 0. Okay? Fine? Okay. So this 2 pi is multiplication with this 0. So this whole term, basically this whole term will become 0. And we know that the sine 0 is basically 0. So it will become 0. So we will only get the two term, that is L by 4, and it will become 0. So L by 2, so L by 2, and this is L by 4. I think we I think we have written a wrong thing. Let me see in the previous page. In the previous page it was 2 by L. So we have just reversed that. So we have to also write over here is 2 by L. So I'm really sorry. This all will be 2 by L. So please check it yourself. This all will be 2 by L. Okay. So 2 by L. So this will be a 2 by L. So this L get cancelled, and 2 ones are 2 and 2 twos are 2. So it will becomes 1 by 2. So the correct answer is, so the correct answer will be this D option. So thank you so much for watching this video. I hope this video make useful for you.